Today we will be discussing Physics 251 Video Explainer Problem 30 of Week 3. In this problem, we're working with vectors and vector components. If you have any questions throughout the explanation of this problem, it would be worth going to the Week 3 lecture and going to slide 17, where Professor Yu does a very good job of explaining kind of the equations that I'm using. And on that note, I'm using the same equations, but I've changed some of the variables just to make it a little easier to understand. So let's get into the problem. All right, so we're going to an amusement park with our friend Betty, and we're pretty much finding her displacement, the magnitude of her displacement vector, as well as its direction. So here I have the kind of givens in the problem that I've pulled out. So we have a diameter of 30 meters, theta of 60, and clockwise rotation right here, or excuse me, counterclockwise. And I've kind of drawn a little picture here to kind of help visualize some of this information. So we have Blue Betty right here in the initial position, and here she is in the final position. And what we're going to be looking for is this vector right here, the displacement vector, as well as its direction. So let's go ahead and get into the problem. We're going to start off by using this position vector equation here to get both the x and y components of both Ri and Rf. And we're going to be using I hat and j hat and not k hat, because k hat is implying that there's there's a third dimension to the vectors. So we're going to start out here by, in the x direction, we have 0 meters, and in the y direction, we have 15 meters. And what we can do is we can think of this Ferris wheel system here as a coordinate plane. And we have the origin right here is the origin of the coordinate system at 0, 0. And this would be 15, this would be 15, negative 15, 15, negative 15, and positive 15 up here. All right. But let's go ahead and get into the RF. So RF takes a little bit of trig. What you're going to be doing is just using SOHCAHTOA to solve for some of the component vector components, and we're going to get 12.99 meters. We're just going to round up to 13 meters in the I hat direction and the 7.5 meters in the j hat direction. Next, we're going to be using this displacement vector equation to kind of group both the Ri and Rf together in the same equation. So we're going to use this, as you can see, here's Rf right here, and here is Ri. And after you subtract them out, you get 13 I hat plus negative 7.5 j hat. After that, we're going to plug these into the magnitude of the displacement vector formula, which is the 13 squared plus negative 7.5 squared, taking the square root of that, and we're going to get 15 meters. After that, this 15 meters is in fact our magnitude of the displacement, but we also need to find the angle. So we're going to be solving for theta, different theta than up here. I feel like I need to point that out, but we're going to be solving for the, this is the direction of the displacement vector. So here we have taking the inverse tangent of the absolute value of the y direction divided by the x direction to give us 29.98 degrees exactly, but we're going to round that up to 30 degrees. So to finish off the problem, we're going to get a displacement vector with a magnitude of 15 meters with a direction of 30 degrees above the x-axis. So as you can see here, we have our vector. This is going to be 15 meters, and this is going to be 30 degrees right here above the x-axis. So thank you very much for watching, and I hope this helped you out.